When you get a simple paper cut, have you ever stopped to think about what's really going on? Your body just springs into action with this incredible, life-saving system. But what happens when that system fails? Today, we are diving into hemostasis, your body's amazing emergency seal, and why knowing how it works could actually save a life. We all get bruises, right? It's just a part of life. But when does that little black and blue spot mean something much more serious is happening under the skin? That question, right there, is why understanding hemostasis is so important for every single one of us, not just doctors and nurses. So, what is hemostasis, really? Well, to put it simply, it's your body's built-in, fully automatic system for stopping bleeding. You can think of it as the hero of our story today. It's this perfectly coordinated response that seals up damaged blood vessels and kicks off the healing process, all without you ever having to think twice about it. Now, it's best to think of hemostasis not as just one thing, but as a whole team of first responders carrying out a flawless plan. This entire sequence has a name, the clotting cascade. It's this incredible chain reaction where each step perfectly triggers the next with amazing speed and precision. This whole emergency response happens in 4 crucial stages. First, an immediate clamp down to slow the bleeding. Then, a quick, temporary plug gets formed. After that, the plug gets reinforced to make a super strong permanent seal. And finally, the body's repair crew moves in to rebuild the whole area. So let's break down how each step really works. Okay, so the very instant a blood vessel is damaged, it does something pretty amazing. It literally squeezes itself shut. This is step 1, vasoconstriction. It's the body's immediate first aid, a muscle contraction that chokes off blood flow to the injured area to minimize the loss right from the get-go. All right, next up, the platelets get the signal. These are tiny little fragments in your blood, and they race to the scene. Once they get there, they suddenly become super sticky, and they all clump together to form a temporary plug. You can think of them like sandbags being thrown into a dam breach. It's a fast, messy, temporary fix to stop the leak while a much stronger solution gets ready. This next step is where that temporary fix gets seriously strong. This is coagulation, the famous clotting cascade we just mentioned. A whole bunch of proteins called clotting factors start activating each other in this perfect chain reaction, and the end result is a tough, fibrous net called fibrin. This net weaves all through the platelet plug, locking it down and reinforcing it, kind of like how rebar makes concrete so much stronger. And finally, with the bleeding stopped, the real repair crew arrives. Fibrous tissue starts to grow into that fibrin mesh, slowly replacing the clot with brand new, healthy tissue. This creates a permanent seal for the blood vessel, and the healing process is complete. It's just a brilliant design that shows how the body not only patches the problem, but completely rebuilds the structure. So that's the system when it's working like a charm. But what happens when something goes wrong? Well, there are saboteurs out there, certain conditions, and even some really common medications that can interrupt this perfect chain reaction. And the consequences? Well, they can be devastating. The main culprits that mess up hemostasis pretty much fall into 3 big buckets. First, you've got diseases that hit our organs, and the liver is a huge one. Second, there are common medications that tons of people take every single day. And third, you have genetic conditions you're born with, like hemophilia, which is pretty famous for messing with the body's ability to clot. So why is the liver so important here? Well, it's because the liver is the factory. It's where most of those essential clotting factors, those proteins that build the strong fibrin net, are actually made. So if the liver is sick, that factory slows way down or maybe shuts down altogether. You just don't have the basic building blocks you need to form a solid clot. Medications are another huge saboteur. Just look at this table. You've got things like aspirin and Plavix. What they do is make the platelets less sticky, so they can't form that initial plug very well. But then you have a drug like warfarin, also called Coumadin, which works in a totally different way. It goes straight to the source and tells the liver to stop making as many clotting factors. The key thing to see here is that different drugs sabotage different steps in the cascade. Okay, this is where things can get a little confusing, because not everything that affects bleeding is actually a true saboteur of the clotting process. There are other medical conditions and drugs that act more like decoys. They seem related, but they don't actually stop a clot from forming. Let's clear up some of the most common ones. Now, you might be thinking, hey, wait a minute. I've heard that beta blockers can be a problem if someone's injured. Or doesn't pancreatitis cause all kinds of serious internal issues? And you're not wrong. Both of those are very serious. But here's the critical difference. Neither of them actually stops a clot from forming. Their danger comes from somewhere else entirely. Let's look at this side by side. Over here on the left, you've got liver disease. As we know, it directly stops clots by cutting off the supply of clotting factors. But on the right, you have beta blockers. These meds don't touch the clotting process at all. Instead, they mask the signs of blood loss. They keep your heart rate from speeding up like it normally would, which basically hides how bad the bleeding really is from doctors. It's incredibly sneaky. So what about pancreatitis? Well, that's a disease of the pancreas, and that organ's main job is managing your blood sugar with hormones like insulin. Now, can severe pancreatitis be life-threatening? Absolutely. But its job is all about metabolism, not clotting. Hemostasis is a totally separate system, run by platelets and factors made somewhere else entirely. And one last decoy to clear up is polycythemia. This condition means your body is making way too many red blood cells, the cells that carry oxygen. Yes, it's a blood disorder for sure, but remember our key players. Hemostasis is all about platelets and clotting factors, not red blood cells. So while polycythemia is a serious issue, it doesn't directly break the clotting machine itself. So after breaking down the whole process, the things that break it, and the things that just confuse us, what's the one thing you really need to take away from all this? Why does this invisible, automatic process matter so much? This is it. This is the whole ballgame. Someone with a healthy clotting system can get some minor internal bleeding, the kind that just causes a normal bruise, and their body fixes it, no problem. You probably wouldn't even know what happened. But for someone with impaired hemostasis, that exact same minor injury can be fatal. This is why a simple bruise can sometimes be a very, very serious warning sign. It really makes you stop and think, doesn't it? Hemostasis is just one of these dozens of incredibly complex, invisible systems that are working perfectly in the background every single second of the day just to keep us alive. It makes you wonder, what other silent guardians are standing by, and what happens when they fail?